All right, in this section we're trying to see if we can make an acid halide. So the first thought you might have is you might be able to take a carboxylic acid and react it with chloride to make an acid halide. There's a problem here because the leaving group, if this chloride came in here and displaced the hydroxide, is OH-, which is the conjugate base of water, pKa of around 15. And Cl- that you're starting with is the conjugate base of HCl, a pKa of around -7. So you're talking about a difference of 10 to the 22 times that this is a better leaving group than this one. So that reaction is not going to happen. And the other problem that you have is this isn't a very good base, but it could be a little bit basic. And if it was going to do anything, it might take off this proton. This is an acidic proton. So this reaction will not work. So how are we going to try to see if we can make an acid halide from a carboxylic acid? So to do this, we're going to use a similar reaction that we used back in the alcohols chapter using thionyl chloride. So if you remember the structure of thionyl chloride, SOCl2. So to figure out the mechanism, we start with our standard, who has electrons, who wants them. So if we remember from the alcohols chapter, this sulfur has a big partial positive because there's a partial negative to chlorine, another one to chlorine, and to oxygen. So this is going to be who wants electrons, and so then we have to go over to our molecule and figure out who has them, and it's one of the O's on the carboxylic acid. So if this pair of electrons comes in, pushing that pi bond out, we get this intermediate with a positive charge here on the OH and a negative charge here. Now this pair of electrons out here can come back down to reform the pi bond because I've got a good leaving group in these halogens. And now once we get here, the chloride that came off before can come in and deprotonate, which makes this chlorosulfite ester. And now we have an HCl in solution. And so that HCl can actually protonate this carbonyl here, which then leaves a chloride available in solution again. So that chloride now can come in and attack here, pushing our electron pair out onto oxygen, getting rid of that positive charge. And now when we look at the structure, there's a lone pair of electrons up here that could come back and reform a pi bond, and out here we've got a really good leaving group. So the whole point of this has been to make this a really good leaving group so that a chloride can come in and displace what used to be an OH. So now this pair of electrons can come back down, reform the pi bond, pushing this pair of electrons off here, pushing off the chloride. And in the last step, the electron pair from this chlorine can come in and deprotonate our activated carbonyl. And that leads us to our acid halide product.